Okay, so now we were looking at how to change this integral into polar coordinates. Okay, so it would help if I knew what I'm looking at. So the first thing I can see from this is, why are you doing that? Here we go. Is that x goes from 0 to 1. And y goes from minus the square root of x minus x squared to plus the square root of x minus x squared. So I have something, I don't know what it looks like right now, but I know that x goes from 0 to 1. And y goes from wherever this thing is on the top to whatever this thing is on the bottom, and it looks the same. So y goes from the bottom curve to the top curve, like this. Okay. So what is that curve? I have no idea. So let's see. So if y is equal to the square root of x minus x squared, then that says that y squared is equal to x minus x squared. So then that says that x squared minus x plus y squared is equal to 0. So I'm going to put the x squared plus y squared together. Minus x equals 0. Now x squared plus y squared, that's just r squared. And x is just r cosine theta is equal to 0. So that says r times r minus cosine theta is equal to 0. So either r equals 0, which is something we're not going to deal with because that's a point, or r is equal to cosine theta. And so these two curves match. So this and this are the same curve. This is Cartesian. And this is polar. So now I have an idea of what this thing looks like. It's actually a circle. Okay, this stuff is in the way. Move. Thank you. Okay, so it's actually this circle. Here we go. Okay, and it starts off, let's see, when theta is 0, it starts off here. Okay. But if theta is minus pi over 2, it starts off here. Okay, so if it starts off here, then it does like this. So theta starts down here at minus pi over 2, And then theta gets bigger, and as theta gets bigger, r goes around like this. And then it comes back around like that. Okay. Now, so minus pi over 2 is less than theta is less than pi over 2, and 0 is less than r is less than cosine theta. If I set cosine theta equal to 0, I get theta equals minus pi over 2 or pi over 2. That's how I know it goes from one to the other. Okay. So therefore, my integral that old integral becomes the integral theta goes between 0 and pi over, no, it does not. Theta goes between minus pi over 2 and pi over 2. And then r goes between 0 and cosine theta. X squared plus y squared becomes r squared, and dy dx becomes r dy dr d theta. So x squared plus y squared becomes r squared, and dy dx becomes r dr d theta. Okay, so this is the integral from minus pi over 2 to pi over 2 of the integral from 0 to cosine theta of r cubed dr d theta. So that's the integral from minus pi over 2 to pi over 2. I'm going to integrate that and get 1/4 r to the 4th. Evaluate between 0 and cosine theta d theta. So that becomes 1/4, the integral from minus pi over 2 to pi over 2 of cosine to the 4th of theta d theta. Okay, so that is 1/4, the integral between minus pi over 2, pi over 2, cosine to the 4 is 1, is cosine squared squared. So that's 1 plus the cosine of 2 theta squared d theta, because cosine squared is 1 plus cosine 2 theta. So therefore, I square that. Oh, and I'm missing a half. So the 1/2 that gets squared is 1/4. So that's the 1/2 that gets squared. Okay. So now I get 1/16, the integral between minus pi over 2 and pi over 2. And now I have 1 plus 2 cosine 2 theta plus cosine squared 2 theta. Okay, well, we got to keep going, because that now becomes 1/16, the integral between minus pi over 2 and pi over 2 of 1 plus 2 cosine theta. And then I'm going to get a half plus 1/2 the cosine of 4 theta d theta. Okay. So I get 1 over 16, the integral from minus pi over 2 to pi over 2 of 1 plus, nope, 3 halves, 3 halves plus 2 cosine theta. That's wrong. This is cosine 2 theta. Plus 1 half cosine of 4 theta d theta. Okay. So this is 3 over 32 pi. At that point, you can get the rest of it. Okay. Example. Find the volume of the solid in the first octant bounded by the cone Z equals R and the cylinder R is equal to 3 sine theta. Okay. Well, the first thing, what does R equal 3 sine theta look like? And what is the cone Z equals R? So Z equals R is what is on the top. So that's the thing that's bounding. So everything. So here's a cone. So I have this cone. Okay. So there's my cone, Z equals R. I know that because Z equals R means Z equals the square root of X squared plus Y squared. And Z squared equal to X squared plus Y squared is the cone that's top and bottom. So this is a top and bottom cone. And I only want the top. Okay, so I only want the Z equals R part. And the cylinder, R is equal to 3 sine theta. So R is equal to 3 sine theta. Let's see what that looks like. Well, that's a circle that looks like this. this height is 3. And so theta starts off like this, r is 0, and then it goes all the way around. That's where theta equals pi over 2, and then it goes all the way back around to theta equals pi. So that maps out the whole thing. Okay, so that's the whole thing from here all the way around like that. But the problem said first octant. So that means I only want the piece that's this. So that says that 0 less than equal to theta is less than equal to pi over 2. And so down here on the ground, it's funny that it won't let me rotate stuff. Okay, so there's a cylinder. There's the cylinder. So we want the volume bounded by the cone. So we want it this piece. We want it bounded by the cone on the top. So what's underneath the, there we go. So this is what we really want. I don't even need that circle. Okay. So the cone is what's on top. So the function of the cone is Z is equal to R. Okay, so now we can see that when we go to do this problem, and I think this is a difficult one. It's a visually difficult one because I only want the first half of it. So I don't want this part over here. I only want the part that goes up to this piece. Okay. All right. So therefore the volume is the integral. Theta goes from 0 to pi over 2. R goes from 0 to 3 sine theta. And the function over top is Z, which is R. And then dr, then I have to do R dr d theta. So it comes out to be a really easy integral. But the problem is that developing it is not the easiest thing. Okay. What do you think about that, Anaya?
What you say? It like cut out.
I said, what did you think about that derivation? It's a little tough, isn't it?
Lord.
They're tough. Okay. So this becomes the integral from 0 to pi over 2, the integral from 0 to 3 sine theta of r squared dr d theta. So that's the integral from 0 to pi over 2. And when I integrate, I get 1/3 r cubed, evaluate between 0 and 3 sine theta d theta. So that becomes 1 over 3. And then, oh yeah, the integral from 0 to pi over 2 of 3 sine theta cubed d theta. So now I can pull out 27. So I get 9, the integral between 0 and pi over 2. And sine cubed, I'm going to write as sine squared of theta, cosine of theta. What am I doing? I'm going to write it as sine squared of theta, sine of theta, d theta. So that's 9 times the integral from 0 to pi over 2 of 1 minus the cosine squared of theta times the sine of theta, d theta. So that integrates to 9 times, integrate sine theta, I get negative cosine theta. And I integrate negative cosine squared theta, and I get 1/3 cosine cubed theta, and it's positive. Because when I take the derivative of it, out pops the negative, evaluate between 0 and pi over 2. And that just turns out to be 6. And that's what I have. Okay, another example. Find the volume of the solid that is bounded Z equal to 8 minus r squared, and Z is equal to r squared. Okay, so now you got to remember Z equal to 8 minus r squared is equal to 8 minus x squared plus y squared. So this is an upside down paraboloid. And then Z equal to r squared is x squared plus y squared is a regular right side up paraboloid. I think I spelled that wrong. Okay, so you have something. So you have one that's upside down. So you have two paraboloids. So you have one that's going like this. And then you have another one that's going like this. And they meet that's where they meet. And so that is the region R that is projected on the bottom of on the ground that you have to integrate over. Okay, so this is the region R that gets integrated over. All right, so down here is R. Now, this is finding volume, is the double integral over the region of Z top minus Z bottom dA. Regardless whether we're doing it with polar coordinates or whether we're doing it with Cartesian coordinates, we're taking a function over the top. So we're finding all the volume underneath it, and then we're subtracting off the volume underneath the bottom thing. Okay, so the only way to find R, which is the region that is to find this region R here, is to find out where they meet. So we're going to set Z, which is R squared, equal to 8 minus R squared. So when I take 8 minus R squared and set it equal to R squared, I get 8 minus 2R squared is 0, or R squared is equal to 4. So R is equal to 2. So that's the circle of radius 2. And I want the whole circle. So therefore, 0 less than or equal to theta less than or equal to 2 pi. So therefore, my volume, theta goes between 0 and 2 pi, and R goes between 0 and 2. Z top, the thing on the top, is 8 minus R squared minus the thing on the bottom. And then I still have R dr d theta. Okay, so whatever you do, when you do R dr d theta, oh, it's stuck again. Come on, I can't, don't be stuck. Thank you. Don't forget that R. You gotta, it's always R dr d theta. Okay, so this is an easy integral. And it turns out to be 16 pi. Okay, any questions, Anaya?
Not as of right now.
Okay, I need you to review this. Don't wait till the last minute, okay?
I know. I'm trying to. I was gonna review everything this weekend because I have to work this weekend, so I'm gonna do most of the homework. Finished it this weekend before the exam, so I have questions for you on Monday.
Okay.